welcome to Best Academy TV. In this video, we're gonna focus on questions and answers on calculus. We are given a question here, and they said, if y equal to 4s raised to the power of 3 or raised to the power of 5, that is this question here, and we are asked to determine the value of the square y over the s squared at s equal to 2. And these are the options here. So this expression here is called second derivative. We have first derivative and we have second derivative. So you can only get second derivative from first derivative. That means I have to differentiate this one first before I will differentiate again to get the second derivative. So let's differentiate that question there. Solution first. All right, now to differentiate any equation, the first thing to do is to identify the function. To differentiate any equation, the first thing to do is to identify the function. Please listen to me carefully. So let's identify this function here. We are given the function, that is the equation here, y equal to class 4s minus 3 raised to the power of 5. Oh, all right, now this function here is called function of a function. Please function of a function. But that's not a problem here. This is what you should understand here. Whenever a function has inner and outer parts, whenever a function has inner and outer parts, the pattern to differentiate that is this. The derivative of that is going to be, that is the dy over the s of t will go to inner derivative times the outer derivative. Please take note. So you differentiate what is inside and also differentiate the outside to get the outer derivative. Please take note. So what is inside here is 4s minus 3. Differentiate 4s minus 3. So our dy ds here, class, dy over the s will be equal to, class, the inside is 4 times the outside is, whenever you take out the inside, what is left is the outside. So what will be left will be bracket open and close raised to the power of 5. So when you differentiate something like this, that is to get the outer, we have 5 into raised to the power of 4. So this is going to be bracket open and close. Sorry. This is going to be 5 bracket open and close raised to the power of 4. So in mathematics, we don't have anything as empty brackets except in set, and this is not set. So the question now is, what am I going to place inside this bracket? It's what is in the bracket from the equation. So I will have the first derivative to be 20, that is 4 times 5, into 4s minus 3 all raised to the power of 4. Please take note. Please, I use this format here. Inner derivative, that means differentiate what is inside. Outer derivative, that means differentiate what is outside. You get this, okay? Now, this is the first derivative. We are not asked to find the first derivative. We are asked to find the second derivative. So the second derivative, I have to differentiate from this first derivative. So our d square y over the s squared will be equal to, class, let's differentiate again. Okay, differentiate what is inside. We have to be 20 times 4. Differentiate the outside. I will have this to be 4. Please take note. Or in bracket 4s minus 3. Differentiate what is outside is 3. So I'll be left with 20 times 4 times 4 will give us 320 into 4s minus 3 raised to the power of 3. We are not only asked to find the square y over the s square. We are asked to find the square y over the s square at a particular point. That is at s equal to 2. So that means the square y over the s squared at s equal to class 320 into 4 into 2 minus 3 all raised to the power of 3. When you evaluate what is inside here, that is 4 times 2 will give us 8. 8 minus 3 will give us 5. So class, I'll be left with this. I'll be left with this 320 into 5 all raised to the power of 3. Okay, 5 raised to the power of 3 simply means repeat 5 into 3 places. When you do that, we'll have 1, 2, 5. So our answer here would be 320 times 125. So when you punch your calculator, 320 times 124 will give us 40000. I guess so. 1, 2, 3, 4. Okay, this is our answer here. Okay. Now let's solve the next question here. This is question 1. Let's solve the next question here. Question 2.